Today we finish up our study on polygons by talking about geometric probability. So what is probability? The probability of an event tells how likely it is that something will happen. Now when we write probability, we write it as a ratio of the number of favorable outcomes to the total number of possible outcomes. Now when we refer to geometric probability, this is a ratio which involves a geometric measure, such as a length or an area. Now, how do we know what the total number of possible outcomes is when we're trying to write this ratio? Well, we call that specific value, the total number of possible outcomes, we call that the sample space. And then in terms of the outcome that you want, the favorable outcome, we call that an event. Now, depending on what exactly it is you're doing geometrically, your sample space and your event is going to look different. So we're going to look at a number of different examples. So let's say you're looking at length. For example, here is a line segment, and you can see points A, B, C, D on it. Now the sample space would be all the points that are on that segment AD, from A all the way to D. That could be a sample space. Now an event could be that red portion that's highlighted there, and that could be what you want, your favorable outcome. So all points on segment BC. So it's some portion of the sample space. So to find the probability, you would find the length of BC and divide it by the length of AD. Now let's say you were looking at an angle measure. So for example, here is a circle, there's an angle measure inside. Now the sample space could be all the points that are in the circle. Now an event, which is going to be your favorable outcome, could be all the points that are in the shaded region. So now to find the probability of this event, we would find the measure of the angle and divide it by 360 degrees. Now let's see if we were looking at area. Let's say you had a rectangle and this shaded triangle, and let's say the sample space is the rectangle, so that would be all the points that are in the rectangle, and the event, or the favorable outcome, is the shaded part, the triangle. That would be all the points in the triangle. So the probability here would be the area of the triangle divided by the area of the rectangle. Let's take a look at example 1. A point is chosen randomly on segment AD. Find the probability of each event. Now you can see here in the diagram, you are told what the lengths are from A to B, B to C, and C to D. So if you're trying to find the probability that the point that you choose randomly is on A to C, you would find the length of AC and the length of AD. So AC, that would be your favorable outcome. AD would be all possible outcomes. So AC has a length of 7 and AD a length of 12, so this would be equal to 7 over 12. All right, the second part, the point is not on AB. Well, if it's not on AB, it must be on BD. So the probability is going to be BD over AD, where BD is the favorable outcome. Now the length of BD is 8, so this will be 8 over 12, which can be simplified to 2/3. All right, the next example. Use the spinner to find the probability of each event. The pointer landing on red, the pointer landing on purple or blue, and the pointer not landing on yellow. So we'll take these one at a time. The probability that the pointer will land on red, that's going to be, well, how many degrees of red do we see? We see 80. So there'll be 80 degrees over the total number of degrees, which is 360 degrees. That can be simplified down to 2 over 9. So the probability that the pointer lands on red is 2 out of 9. Now the pointer landing on purple or blue. So in order for the pointer to land on either purple or blue, we can add those degree measures together. So 75 plus the 60, and put that over all the possible outcomes. So that's 360 degrees. And we can simplify this to 135 over 360, which can be simplified to 3 over 8. So there's a 3 out of 8 chance that the pointer will land on purple or blue. All right, and the pointer not landing on yellow. For the pointer to not land on yellow, that would be everything else. So to find that, we can do 360 minus the 100 degrees, or if you wanted to, you can add all the other degrees together, 80 plus 45 plus 60 plus 75. 360 minus 100 is probably a little bit easier, but you should end up with the same answer either way. So we end up with 260 over 360, which can be simplified to 13 over 18. All right, here's our last example. Find the probability that a point chosen randomly inside the rectangle, that's the large shape that everything is inside, is in each given shape. Round to the nearest hundredth. So to find the probability that a point chosen randomly inside this rectangle ends up being in the trapezoid, we would have to find the area of the trapezoid and divide that by the area of the rectangle. Now remember how to find the area of a trapezoid? That's the 1/2 times height times base 1 plus base 2. And then the area of a rectangle is base times height. So in the trapezoid, we have a height of 10. We have base 1 as 3 and base 2 as 12. And then in the rectangle, the base times the height, that would be 45 times 20. Simplify this as much as you can. So we have 1/2 times 10 times 15, which is 75. And then 45 times 20 in the denominator, which is 900. And then we can simplify this down to 1 over 12. All right, and then this last one here, what's the probability that a point that you choose randomly inside the rectangle is a point inside the circle? So here, we're going to need to find the area of the circle and divide that by the area of the rectangle. Now remember, the area of a circle is pi r squared. And the area of a rectangle we just found, base times height. So the circle has a radius of 6, so this will be pi times 6 squared. And in the rectangle, we have 45 times 20. And simplifying this, we end up with 113.1 over 900. Now if you want to, you can absolutely change that into a percent in order to perhaps understand exactly what that looks like in terms of a probability, but you can absolutely leave it as 113.1 over 900.